not all employees are janitors, and therefore I cannot accept a generalized input. Therefore, I need to specify it, and specify it for employees manager. Oh, sorry, I just disconnected. So sorry. I asked you guys, why doesn't this work? Why doesn't employee, why can't I pass any employee to the manager in this loop? Can anyone answer? Also, Joe Striker, just ask a question and I'll try to answer. Yeah, because it cannot treat employee as janitor. However, can employees manager treat janitors as employees? The answer is yes. Therefore, specifying the manager input type for employees manager works as well as for janitors manager. Yeah. Well, all janitors are employees, but not all employees are janitors. Therefore, it works if I pass it a janitor. Because if you look at inheritance, a janitor is an employee. So all employees aren't janitors, but all janitors are employees. So that's why it works. Is it clear? I really need to know. And ask if you have questions. I'll try to answer. So contravariance is the opposite of covariance. It simply means that the input that we take can be specified, but cannot be generalized. More rather not the input. So input can be generalized no matter what, but the generic type cannot. So what's the part, what troubles you? Like, what can't you get? What is the question that you have? Because it's important to understanding. iManager for janitors is also iManager for employees. Well, the other way around. If I can manage if I can manage employees, that means I can manage janitors as well. And certainly those two don't share common behavior. Those two are not polymorphic by themselves, but the input that they take is. How can you pass in employees manager? I can pass in employees manager in here because both are of the same type. And since it's contravariance, that means that something that is general can be specified. So something that was general, like employee manager, can be specified as iManager janitor because it's contravariance. If I mark a generic type with in, where for its t, That means that when I call or store all those managers, all those generic types, I can store all those into a specific type as long as they still share the inheritance hierarchy, the same tree. And yes, guys, it's about not the polymorphism of this whole thing, but the polymorphism of this. Janitor is an employee. Therefore, iManager for janitors can take either employees or janitor managers. Just let it sink, maybe come back to this a bit later. Well, I think the answer is in the slope. Like, if you, okay, imagine that this worked, that I stored it like this, right? Imagine that this worked. Well, imagine that there was no error here, right? So you have managers for employees, right? And then you say, so manage every employee. What if janitor's manager doesn't know how to manage a programmer? But by writing this, I essentially say that janitor's manager can technically manage programmers as well, which is not true. So if I generalized it like this, I would be lying. Janitor's manager doesn't manage employees. It only manages janitors. What if a programmer comes in? How does janitor manager deals with a programmer? And so even though it might make sense to write this as an employee iManager, it does not, because it just deals with janitors. So now I say deal with janitors, and it does. Well, you will learn this as long as you don't give up. Let's move on. So, summary for this contravariance and covariance. Covariance is when you use out and you can generalize your generic data structures, and contravariance is when you can specify your generic data structures and when you use in modifier. Next. So recommendations. You might, so the thought of when should you use generics might have crossed you because it awfully looks familiar to polymorphism. Again, with polymorphic behavior, we treat different types as one. With generics, we treat different types the same way. So it sounds very similar, but at the same time, there is one key difference. In polymorphism, you normally have multiple different behaviors which can be invoked through the same method call. However, in generics, you have a single behavior which takes different types. And that's the key difference. Multiple implementations across different types versus a single implementation for different types. So overall, if you can use polymorphism, use polymorphism, because that's a more common case. Because objects are usually generalized, and if they can be generalized, don't put generic constraints on top of them, because there is no point. It's just an extra complexity that you don't need. So why do we need generics? We need generics because we want to work with those specific types. That's the benefit of generic. When we take something, we can work with that something as is, not as a generalization, but as a specific type. In the context of class, which has a generic specified, we work with a specific type, not with a generalization, not with something that we don't know about. And that's a huge benefit for generics. So when it's worth it, when it is such a context, go ahead and use generics. And so sometimes we have absolutely unrelated classes, and sometimes we still want to treat all of them in a generic way. But leaving it wild, leaving it unconstrained, and letting anything go would simply invoke and result in many, many errors. So there is a way around to constrain something, to constrain what types you want to pass to your generic, and that constraint is called a maker interface. So when there is no constraint you can make explicitly, normally you can just give a label to a class. So a maker interface, which is something like there, is simply an empty interface used to mark a type that basically it's used to mark a type. That's all. So car and human has nothing in common. However, they can be created by a factory. They're factory items. So I can say that in this factory, I create only factory items. I don't create anything that can be created, but I only create cars or humans. So maker interface is a way to give constraints to something that is unrelated. Basically, add labels to your class. Now, is it something that you should do often? And the answer is no. Maker interface in general is considered bad practice. But I think it's worse practice to let everything in and do validation inside the generic. Because you get free validation if you constrain a class that really needs that with the maker interface. It's cleaner that way. So, like always, there is nothing absolute, and maker interface, in my opinion, does have some room in your code base. A rare place, but it has one nevertheless. So to summarize again, use generics over polymorphism only when you need to explicitly deal with the generic type in the context of handling it. So, for example, a list is not taking objects, because object is everything, right? It's taking T, because when you get something or when you add something, you also want to work with that something immediately. Therefore, getting and adding takes a generic T so that you can immediately work with a specific type upon retrieval. That's the whole point of generics. That's why it's so nice to work with lists, because you can immediately work with the type you added or retrieved. Really cool. Okay, so that's it for this lesson. Now, do you have any more questions? And anyways, I would really appreciate if you would write one thing that you think you understood very well and one thing that you would like to know better. So one thing that you think you understood very well and one thing that you would like to know better. And I would like it to be written in detail, like one full sentence, not just a topic, so that I can verify if you understood it or not. I'll give a few more minutes to write something. In the meanwhile, let's add the material. I will not post homework yet, as it will come with the third homework, and it will happen tomorrow. So tomorrow I'll try to create tests for the homework and link it in the homework and notify you. So really, guys, silence. Come on. Need to know if you understand or not. Well, yeah, that's the best thing. But really, guys, I would appreciate if you would not just answer if everything is clear or not, but if you could verify it by basically summarizing a thing or two that you learned in the lesson with your own words. This would help me understand and see if you truly are able to explain something, because in my opinion, if you truly understand it, you should be able to explain it to anyone, really, regardless of being new to the topic or not. And through your explanation, accurate or not, I can see a degree of your understanding. Also, let me give a link to the slides. Because personally, when I was learning from random internet sources this topic, it was very hard for me to understand. And a year ago, I wasn't able to understand it. So I presume that you might not be very fluent with it as well. Okay. Sorry for looping images. So slides, git branch. Actually, yeah, that was good. Here. you shouldn't be going deep. You should go straight, as simple as you can. Just whatever is in your head right now, like what's the most memorable thing from the lesson? Can you just tell me that? That will help. As simple as that. You don't need to be too accurate or too detailed, just a single sentence, which would make a point. So, Catgirl said, covariance is used when something has an output, because like different employee divisions might have different employees, but they all return an employee. That's why covariance makes specific stuff into something general. So from reading this, I might have an impression that you think that it always returns an employee. But it doesn't always return an employee, and I think I made a mistake by explaining that a bit. So, right, so if I call a specific division, like game division, right? And I say get employee by ID, and let's give it a GUID. So I can get either a game dev, because that's what game division has, or I can get a programmer, and both things work. It doesn't have to be generalized. I just have that option. That's what it means. See? Game division returns either game dev or programmer. Like I said, when you have generics, the ability to get specific type is always there. That's the benefit of generics. You never lose it. Right, so Roloff said with variance, so it's not variance but covariance. So what you mean with variance is actually covariance, and what you mean with covariance is actually contravariance. But this term is also confusing. But about the rest, you're correct, Roloff. So overall, you definitely got the point. So see, guys, how nice it is to have your own definitions of the lesson. Because in this way, I can evaluate your understanding and clarify if you don't. But if you don't say anything, I won't know what to clarify. And it's, in most cases, when teachers ask, do you have any questions, people don't say anything because it's very hard to ask a question. But it's not that hard to explain what you understood. Just say what you think. Let your thoughts go. And in that way, I will know if you understood the topic or not. In which case, I see that you did. It's just small misconceptions that I could explain through your remarks. Yes, so don't say that you understood the topic. Instead, say what you understood. In simple way, don't overthink it. Just a few simple sentences. And this will be beneficial for everyone because I will be able to explain something that I didn't explain well, or correct myself if I explained with mistakes, and others will be able to learn from what you said as well, or maybe have a matching opinion which wasn't entirely correct. So it's very useful and very needed to be able to express yourself after the lesson. So yes, to summarize, generics always supply us with a specific type. Generics, very much like polymorphism, allow us to work with different types, but in a single method, in a single data structure. Generics basically reduce code by a lot if you use them wisely. And we have covariance and contravariance. All input is contravariance and is marked as in generic type. All output is marked as covariance and is so covariance is something that you can generalize, and contravariance is something that you can specify. And yeah, I mean, to use generics, you don't really need to understand what covariance is or what contravariance is. Like, it is something that is not needed right away, and definitely not needed for basic cases. But it's something that will be needed eventually. And since I won't be coming back to this topic in more detail, I just wanted to explain everything. One more thing, constraints. Generic constraints with generic. So here is an advanced case that I forgot to show. That is decently important. Imagine if you have an interface for entity, and entity has ID of any type. Imagine you had a data store which can store entities, specific entities. So basically, you cannot have this, you need now to somehow specify that entity is actually this kind of entity. And if I just do that and try to say that it's I entity, like I cannot really do that. This is still a generic type. This is not this. So I need to specify that I can store T entity, which is I entity, right? It still makes sense. So T entity is I entity, but it needs to be constrained by something. So I need another generic. So it's constrained with another generic. So this is an example of when you constraint, when you have a generic of generic, when you have a constraint on generic. Sometimes it happens. Again, I'd say this is like under 5% of all the generic cases. So it's not a very common one. Okay, Aurora said, well, contravariance is used when it has an input because something general might be able to treat something specific, like in this case, a general manager can manage a janitor. Very well said. Indeed, in contravariance, we work with we can specialize our managers, our data structures, because the key thing that we're working with is with input. We don't really generalize managers themselves, we generalize input. So, and we don't generalize input, we specify it, because whatever can work with a specific type in a specific manager So in General Manager, it can work with a specific type as well, because the specific type for input can be generalized. Therefore, we specify stuff in contravariants. And yeah, this is an example for generic on generic constraint. Is this example clear? Basically, we say that T entity is I entity, and I entity has a generic, so we passed that it's still a generic. Yes, that is correct what you said. So we generalize input or specified. So the thing that I'm showing now is we have interface for I entity. So we have entities, basically objects that have IDs. And ID can be any type. It can be an integer, it can be long, it can be a GUID, it can be a string. All kinds of types that make sense. But then we have a data store. So we store or get something that is an entity. But to store an entity, we need to specify what is an entity. Entity, we want to store only I entities. But I entity is a generic itself. So we have a generic data store that stores generic entities. So we need to specify a constraint for something that is already a generic. And for this, we need another generic type so that we can constraint that, so that we can complete a generic constraint by giving it a generic type. And what Rorolov said, so the I data store can only store entities which also have TID, and that is correct. So just wanted to not leave this behind and mention this one. How to have constraints. Constraints on constraints, basically. Also, you can have multiple constraints. For example, I can say that I have something else for now, right? So I can have multiple constraints on different constraints. And you have to put it in another line with another where. So this is probably as complex as it gets. You won't have a more complex example than this. Any questions about this one in particular? I'm not asking you to fully understand it, nor that it's fully needed to understand, but just to be aware that you can do this is important. Also, I'm guessing that this is how you would constrain it so that like you can compare one type with another. I'm not sure if I understand your question, if it was a question or just a note, because I don't see what you're asking. Okay. But yeah, this is literally all that there is to generics. You won't go more complex than this. There is no more concepts in the generics. This is considered what a mid-level developer would know, or even a senior. Not all seniors know about covariance and contravariance, and you guys know that already. So this is very nice. But yeah, generics are considered already a junior or mid developer topic. This kind of a generic is a mid developer topic. So Catgirl said, if you want to create a list that has a sort method, it needs to be able to compare what's inside. So you would add something like ti comparable, something like that. Yes, that is correct. So yes, that's all I had to say for this lesson. Do you have any more questions, remarks? Because I have nothing more to say. Tomorrow I'll have a lot of work to do, which is adding homework, 2 branches, tests, and I promised a book, a mini book on object-oriented programming that I've been working on. I am like 80% done, so hopefully I won't procrastinate that and release it tomorrow. Oh, it's a hard question, Joe Striker. So I-comparable is something that you can compare to. I-equatable is something that I see on structures, though I cannot answer it very well. I never used I-equatable, though it's recommended for structs. I don't use structs that often either. All right. So that's it for this lesson. Joe Striker, hit me up on Discord and I'll answer you that question after this lesson, so I can just take my time and do a research. So thank you guys for watching and see you next time. The Discord link can be found in the description of my channel. Let me give you a link. All right. That's the link. So see you there. And good night, guys. Thanks again.